Alrighty, is everybody ready? Everybody got a drink? Everybody good to go? Okay, well then, thanks everyone for joining again. As you can see, it's now me and not, usual Kevin. Kevin moved to the States, so that's why he's not here. I checked with him before the event. He's doing well, he's doing great. Also, Zakir Burker, you may also know him, helping out for the meetup. He's now moved to Singapore, so it's all down on my shoulders to welcome you here. But again, welcome. So it's good to see you all. Just one thing first, there is actually a restroom over here if you need to go there. And again, drinks are in the back. Feel free to grab some more. Another thing I want to let you know is that we're actually live streaming this so that you can watch it back later, and maybe there's some people watching as well. Now, don't be worried. It's over there, the camera there, so you won't be recorded. It will just be the speaker and what you see here on screen. The other thing is that the drinks are kindly sponsored by KintoHub, who is also providing the speaker today. So can you guys show who you are, the KintoHub people? All the way in the back. Awesome, awesome. So if you have later on a question on KintoHub, find these people. Also, of course, thank you, Garrett Society, for again providing us this venue. Without you, this wouldn't be possible. So thank you so much. And I want to introduce actually Heyu, who is going to tell you a bit more about Garrett Society. Just give you.
Okay, I think this is okay, right? Thank you, Bart, and just want to welcome everybody. I see some familiar faces, so you might know what I'm about to say as I welcome you. But for those who don't know me in Garage, my name is Heyu. I work here at Garage Society, and we're a co-working space with 4 locations across Hong Kong. And I actually manage Garage Academy, which is our knowledge sharing platform. So every week we have different events to support the startup ecosystem and the business and startup ecosystem. And so we've supported Bart and his communities for a long while now, so really happy to be supporting JavaScript this week and hopefully more times to come. This is our campus, actually, our Garage Academy campus, so welcome everybody to come back for more events coming up. So yes, it's already here. So yeah, our co-working spaces, we have 4 in Hong Kong, and then we're also in Southeast Asia, in the Philippines, Cambodia, and Thailand. And we're just opening in India this month in Gurgaon. So really welcome everybody to check us out. Happy to offer you all a free day pass to try any of our locations. So you can either email hk.enquiries or just find me and I can get you set up. And then, as I mentioned about Garage Academy, we have a number of different categories that we focus our events on. So tonight is focused on community. We do a lot with business and career development, innovation, startup support, hot topics. And then we partner with, you guys know there are a lot of events in Hong Kong, so we often receive promotional codes and we just support the outreach of different events happening across Hong Kong. And then if you would like to join our digital community, it's called Garage Commons, and my colleague Fiona should have given you a little flyer and a pen to introduce you to it. It's free to join. It's just a membership platform for you to find out more about our events, about people in the community, and we have more in-depth workshops that we hold that are paid, and through Commons you can get a discount to access those. So I really encourage you to check that out. And then just to share with you what's coming up soon, we have a LinkedIn workshop. We have this is going to be a health tech event on December 10th. That's not yet listed, but it's with Entrepreneur First, which is I don't know if you've heard of them. They're a pre-idea accelerator supporting the growth of different companies in Hong Kong. So find your founder, create your own company. So they're recruiting for their next cohort. And then we do have a content calendar workshop. If anyone works in marketing or knows of your colleagues in marketing and want to, you need to promote your content in 2019, it's a great way to set yourselves up for that because 2018 is almost over. Can't believe it. So yeah, here's a QR code, and we have more information in the back for you to check us out. So welcome everybody again, and hope you have a really wonderful event. As Bart mentioned, the bathrooms are behind me. Enjoy the drinks, and the Wi-Fi password is on the wall there. So it's GS1Chai guest. Login and the password are all lowercase guest. Both of it is guest. I'll be sticking around, so please feel free to come find me with any questions. Thank you.
Thank you. All right. And with that, we're going to get started with the talk now. So Roman, please come up and give him a warm welcome to the stage, everyone.
Hi everyone. So today's talk is going to be about microservices, and particularly I'm going to share all the links later, like in case you guys want it. It's all publicly available. So today, basically, we're going to be talking about microservices in your Redux TODO app with Node.js and Mongo using KintoHub. First question is, how many of you are what? Louder. Louder. Okay. Can everyone hear me everywhere? Just a question. Is it okay? Is it okay there? Okay. It's okay, Francois. Don't worry. So first of all, how many front-end devs we have there? Can you raise your hand? And Node.js backend. Who is aware of microservices and how that whole thing is working? Okay. Kubernetes, you guys use that? Anyone? One? Really? Two. Those guys too. Okay. Okay, cool. So I hope you are familiar with React and Redux. In the meeting notes it says it's Preact. I looked into any good examples, but Redux has a pretty good one. It was really easy to adapt to what we're going to be showcasing today. So first of all, you're going to be asking me who am I. So again, my name is Roman, and I'm a backend engineer at KintoHub. Besides that, I've been doing a lot of UI, UX work before that. I mean, front-end included, mobile work. Mostly concentrated on the backend right now, so I'm doing this glue between what you see on the client side and the DevOps side with Kubernetes. So, and what is KintoHub? KintoHub is basically a platform that allows you to orchestrate your microservices using Kubernetes, bringing your front end and your services all together using our special sauce. All right, so the problems that actually are persist right now with all kind of entire development in our minds is, first of all, people are doing monolith apps all over the place. It's done with a single stack of like one language or maybe two at least, and it's eventually, as the business grows, it becomes this one big clutter of code that's really hard to manage. Like there are hundreds of people can work on the same application. It's really hard to decouple, share code. It's not modular. It's not maintainable in the long term. Like eventually, a lot of businesses get out of business because they have way too much maintenance on their hand. It's too expensive. Orchestration and scaling, that's a bit of a problem as well, because if you wanna do business locally, that's kind of fine to stick with one instance or whatever. But if you wanna scale outside of your country, like global-wise, you need to understand how you're gonna scale your service and how you're gonna orchestrate basically the connection between the different pieces and how to decouple them in the right way. CI/CD setup usually comes separately. Again, you need to hire separate people, usually DevOps people that's gonna leverage that for you, set it up for your development team. And it's additional maintenance, it's additional cost that can be avoided. Database management, huge things, like completely separate people are handling that. Protocol translations, the way the whole World Wide Web works, any communications, like different system has different protocols. The problem is when you want to use one protocol to communicate to service that uses another protocol, how would you do that? Especially it comes really important with big data, when you need to analyze a lot of stuff and a lot of different distributed systems. It's a bit of a problem, especially when it comes to HTTP gRPC, and gRPC is Google's protocol for really fast communications, and usually it's been used in gaming. Service discovery, again, when you scale, how one service would find another service? Routing is a big problem. Documentation, things have been constantly developed. Like there's a lot of code being developed each and every second, and there's a really big lack of documentation on that code. So, and whenever somebody comes to a code base, like it's really hard to align pieces together. A/B testing and separate environments. Again, you have separate team to manage that. It's a separate production, maybe like separate clusters, and again, it's a big plan. So the list goes on with the current development state. So the way we believe things should be like, they should, all the code pieces you build should be built in a modular-like way. So it's going to be more scope to resolve a particular problem. Less code. The best code in my mind personally is the one that you never write or you don't need to write, because any code that is just written additionally, not resolving much, is just adding the clutter and maintenance. Like, you better not write code if you can avoid it. Language implementation agnostic development process, that's related to actually, I think, kind of people issue or the recruiting issue. Basically, the problem right now is that every business would be looking for particular developers, like C# developers or Java developers. Any language is really specific to what business is doing, what kind of technology stack they have. The way ideally it should be, the business should be looking for a developer, and developer should be able to, with enough experience, to provide a solution to a particular problem using any language that he is proficient with. So that removes a lot of clutter from the business to find particular professional, and a lot of problems for developers themselves, because I know a bunch of my friends, they would say not be able to find a job in a particular place which is dominated by certain technologies. They would need to, move places, move countries. It's a hard, also like mental issue to deal with, but it happens, especially with not well-developed region where you don't have a lot of selection. It's usually dominated by one or two particular environments. Autoscaling and orchestration should be also coming out of the box. You should not be bothered with knowing like how to scale or when to scale. Your service should just auto-scale based on loads that you get inside. Auto CI/CD, again, people should not be spending time on that because, again, it should be just a part of the system that provides you with the orchestration. No database, that's actually an experimental thing we are planning to work on. Basically, as a developer, you usually only care about the data. You least care about the database. You only need to get the data, understand how to process it based on the query, give the response to the client. So one of our proof of concept is going to be by providing you with your data. It's going to be still secured in your domain with your database. That is going to be on our side, but you'll just be busy with providing the particular query for that data. We're going to be handling basically delivery of that data to you. It's something we can talk about later. Protocol translations, again, those should be automated. So HTTP should be able to talk to gRPC, back and forth, gRPC to gRPC, the socket connection. That, again, developers should not be bothered with that. Auto service discovery, again, relates to the same thing. You should just know the endpoint which to call, which is going to resolve your endpoint query, or the endpoint service that's going to basically give you the response. And auto documentation. That's ideally, in ideal world, that should just happen automatically as you write your code. And there are other things also. That's basically a giant word that I would write on top of it is automation, which is development is all about, and we feel like we don't have enough of it with the current state of things. So what can be done with that? Solution to that is you do your microservice architecture with the scalable cloud orchestration. The problem only is that this thing is kind of hard, because aligning all those random pieces together, providing developers with the cloud agnostic environment or language agnostic environment that allows them to develop with any language that they like, resolving real world problems, it's a pretty tough problem to tackle. And big businesses, they spend a lot of efforts, a lot of investment into making particular solution happen. This particular image right here is actually from one of our discussions, how things are aligned together. You see, like, there are a lot of connections there. And to compare that, like, this is the amount of code, and this is our TowerFall score here. So this is the amount of fun you have, and this is the amount of work you need to do when you trying to build your own orchestration on Kubernetes. And the entry barrier for that really high. It's not only the Kubernetes that you need to know, but also the services providing you the storage, the routing, service discovery, the build process. Like, there are so many layers that you need to align together. It's tough. Possible solution to that is KintoHub. The current state of things, we already provide you with the platform that's getting really close to that ideal picture that we have. The basic flow is you have your subversion somewhere. Right now we support GitHub and Bitbucket. So you connect your repo, you do the build of your like whatever application you have there. You combine it as a set of microservices together, deploy it, and then you call it using our gateway. So that's the bulk of it is pretty much this flow, and it should not be more complex than that in our minds. It should be pretty straightforward and removing any like additional maintenance that you might need to have there. The entry point to our service is the gateway. Basically, any call you need to do to your service, you do that to our API endpoint using the GWT authorization token, which you get, and then on every to reach any endpoint, you use that token as a bearer. And you can talk to any service. You can talk to any environment, and you can talk cross environments or even cross clusters. Like so, people that are doing microservices here, they might say, well, you usually authorize once, and you kind of have the access everywhere. The problem with that is that's all good until you have it like as a one environment and maybe a couple. But when you need to orchestrate your things across environments, across clusters, reaching different microservices, different microservices within those different clusters, you want to have a means of authorizing that request to understand where it's actually going. Based on that, we also can gather you the metrics along with that request, as also like the end-to-end security and encryption with that request. So now I'm going to show you guys a live demo how generic example looks to deploy your single microservice and two microservices actually. One is acting as a web application facing client. The other one is the backend server. So I am going to switch right here. All right. Let's do this. No. Let's do this. Shift N. Oh, it's opening here. Sorry. So in order to get to the platform, you type in KintoHub.com. First thing you need to do is register yourself. So I usually use the temporary email service for registrations when I don't want to expose my email. So you can use this one. It's pretty good and it's pretty easy to use. So this is the email I'm going to use. So sign it up. By the way, any questions so far? Like anything you want to add or ask while I do this process? No? Oh, cool. Okay. All right, so I am going to skip the tutorial because that's what I'm going to be presenting today. So here you see we send you the activation email. Before you build anything, you need to validate. You kind of can do certain actions, but we do enforce it when you actually need to create the Kinto blocks and deploy your app. So I guess you can log in. Okay, yeah, it's all cool. So I think we don't need that anymore. So okay, after validating the email, first thing you want to do is connect your GitHub repo. This is the set of workspaces you have. You can have multiple workspaces that have different multiple environments inside. By default, you're limited to 2. And you can have, I think, 4 apps and 10 Kinto blocks inside. Kinto block is your microservice, basically. So let's connect the GitHub first. All right, and you see it's connected here, and it's exposing the organizations I have. So the question you're probably going to have, well, what if I don't want to give you the access to repo? Because we do need read and write access. The way you can limit it, like say in your organization, you can create a separate team under that organization that will gonna have only access to certain repos. And we're not going to see the rest of your repos. But we do need the read and write access. And for you to check that, because we already seen a few cases where people would search for their repo and, hey, where's my thing? And it's not there. And that's because of the read access. But we really need the right to connect your things. So after connecting the repo, this is the microservices section, basically. We call every microservice. It can be, because it's a larger abstractions, it can be a microservice, it can be facing client application, or it can be like a cron task, like a task thing that we're going to introduce later. Right now, you have available two types. So first one I'm going to create is the microservice one. And we support number of languages here, including Elixir. But some of those are experimental environments. But the one we're going to be using is Node.js. And yeah, currently we support only particular versions. That's due to technicality of provisioning, like abstract environment. Our future plans are to support functionality that would allow you to just select the language, then select the version, and we're going to provision that to you.
Sorry, question then. What if there is an upgrade to Node? How would you be able to upgrade the...
Well, we're going to be fetching all the latest stable ones, so you'll be able to choose from that. And for web apps, you'll be able to basically provide your own Docker image where you would be able to install whatever version you have. But that's like a custom service, and you can do it in web apps, actually. But for microservices, we're gonna limit that for now until we get to a stable point when we can provide you with any environment, basically. Right now, it's limited to a certain selection. So Node service 1. Okay. So I recommend you to use the pre-populated one because this is gonna basically push the example boilerplate project for you with documented endpoints. It's ready to go, like simple Node.js server that you can start from building your thing. And it's gonna also align you with the API doc, which is the tool we're using to basically document your microservices. And I'm going to choose probably KintoHub because that's where we store all the unreasonable temporary repos. You would be surprised the amount of repos we create every day. So we're not going to expose our main organization anytime soon. So here, you see, based off the environment I select, so if I say select Java, it modifies the build command. Those are the things you need to provide in order for us to build your application, because it can be really specific. So, but we do provide you with boilerplate inputs there. So for Node.js, it's simple npm install and npm run prod. Then you're probably gonna want to stick to HTTP first. And I mean, if you're into gRPC, then you can use that. But for the point of example, we're gonna use HTTP. And currently, we do enforce the API docs. So if you're gonna push your service without the properly documented endpoints, that build is gonna fail. But within actually next 2 sprints, we're gonna make API doc to be optional, so you'll be able to deploy like any service basically without the documentation. The one point to keep in mind: if you do push it like that, you won't be able to share your blog to the rest of the community, because other people need to know what your service is doing. So you can keep it for yourself, but for public ones, we are gonna still enforce the API doc or Swagger, which is the open API. Okay, I think we're ready to go. So after that, well, you create your blog. Behind the scenes, we provision the repository for you and populating that with a bunch of boilerplate files. And it's all cool. So, and it's already scheduled for a build. So now if I'm gonna go to that repo, you're gonna see it's pretty simple, small Node.js application. Inside, this is how API doc documentation looks like. And you see it's much smaller than the Swagger one, and that was one of the reasons we choose that, because it's much more descriptive in what's going on with your endpoint. So basically, you specify your endpoint, what's the method there, what's the success responses. Yeah, it's pretty straightforward. So basically, on the response, I'm gonna give back the hello world with the passed message. Okay, so in the builds, I actually wanted to show the Argo build system that we have for builds. So this is our build system that we have behind the scenes, and this is the currently built Node.js blog. You see we have a bunch of steps going on inside there, but it's already done. So if I'm gonna go here and back, it's already a success. But just wanted to show you this particular service, because this is something we probably gonna expose to our clients as well. And it's really helpful in terms of figuring out what builds. That's basically your CI/CD. So, and it's really easy to figure out what's going on, or what is failing, or where the connections are going, and kind of track the flow of your build. So the build is successful. With that, after the build is successful, I can check the endpoints, which is the auto documentation that comes thanks to this thing right here. And you see we specify what is the endpoint, what are the incoming parameters, and what's going to be the response. So this is all good. And with that, I'm also going to create a web application. Web app, simple app. Nope. Oops. Sorry. App. No. Okay. There we go. And we have 2 flavors: the static one and dynamic one. Dynamic is basically kind of like a usual Docker image that you would supply to, say, the AWS, and that would spawn an app, client-side app that is supported by the Node.js server. So this is the dynamic one. And static one is the one that's just going to run the build and serve the static files out of that. Makes sense to everyone so far? All right. So I'm going to choose that, and I'm going to provide an existing repo. So this is how you basically search for the stuff you already have there. Node web, I think it's called. Yeah, so this is the one I'm going to be using. And port for that is 5,000 as far as I remember. Yeah, I think we're all good. So now we create this thing. It does the same thing. Basically, it's that's a Preact app actually. A Preact boilerplate thing, easy to use with the webpack inside. But it's a pretty easy example to showcase like a full-blown web application with the Node.js server. Okay, so and now we on Argo side in workflows. I'm gonna check now this thing is being built, and you can see we have build steps going. Like the Node.js microservice takes much faster than the web app. This one is taking longer. The Node.js is like around 30 seconds, and web app is going to take like usually around a minute or two, because we need to build the entire thing. Then we grab all the artifacts, put that to our storage, then we will be able to provision that when you deploy your application. And maybe we can check some logs. I don't know. Yeah, there's a bunch of stuff going. All right. So the next sprint, you see we provide you with estimates right now. Next sprints are going to be actually, like right now I need to, refresh the thing. But following sprints, we're going to introduce real-time updates for builds and real-time updates for deployments. So for that thing, we currently need to wait a bit. But before that, I think I can go ahead and set up the deployment. So deployment is, you should think of it as like a combined set of your microservices, basically. So, and it's going to be handled by one authorization token, depending on which environment you deploy. And those services, they can freely communicate to each other, and they actually can communicate cross environments and even cross clusters. So sample node and Preact thing. All right. So I'm gonna add them both for now. And I'm going to talk about this section later, but this is what I'm going to be using for our more real-life scenario application. And you can see if the builds, if particular application had a successful build or not by clicking here and choosing the. This is basically your branch. When you add a new branch, we provide webhooks there to fetch that updated data, and it's going to be updated on KintoHub as well. So I'm going to select that. For that guy, there's no successful build yet. But let's try and create a deployment. Okay, and now let's go back and check what's the status of our sample app. Yeah, it's all cool. Okay, so now what I'm going to do, so I'm going to tag and deploy. By default, we provide you with the master environment, but you can supply, I think, 10 more environments. I'm not sure, but at least 2. So I'm going to provide the version. You can specify your nodes there. And amazing, it's deployed. So one thing to keep in mind here, we're not going to spawn immediately the Kubernetes pods for you, because otherwise they're going to just consume the resources, and we don't want to do that unless you really want it. So the first thing you need to do is actually open this tab right here. It says how to access stuff. And first thing you need to obtain is the authorization token. So I'm going to copy that, and I'm going to go to my fancy console here. So this is the thing you're going to be using for communicating between your microservices or calling your microservices. So the tool I'm going to be using is probably familiar to all of you. It's Postman. So here, behind this one, I'm going to use this one. No, not this one. Let's duplicate this tab. So in the authorization, basically, it's a simple authorization. There is no like additional digest or anything. It's just a bearer token authorization, but that allows us to figure out which application and which environment and which workspace you're using to connect with your stuff. Then where's our thingy here? Oh, there you go. No, that's not the one. This one. So now you see we provide you what format you should be using for communicating to any service, basically. You communicate with that through HTTP, but even if you use gRPC, we're still going to be able to translate that to your gRPC service. So, and yeah, I just need to provide the name of the block and the endpoint, which again you can just check here. It's dash sample with the message. And so what's going to happen next?
Can you make it a little bit bigger?
I don't know. Can I do it? Oh, yeah. Is that visible? Okay. So what's going to happen next is request API is not going to be found, which is not good. So wait, API.KintoHub. Oh, right. It's sample message. Okay. Yeah, if you call and you see, you get the immediate response, which is actually what's happening behind the scenes. Kubernetes on your first call provisions the pod for you. So until you do that first call, the first calls can take time and it can throw an error, the first one, but the subsequent one are pretty fast and like your pod is basically already working, so you don't need to worry about that. So this is our service working behind the scenes, and we can, I think, check the log requests for that. They're a bit slow, but we do provide you with stuff every 5 seconds. We use Elasticsearch and Kibana behind the scenes, which is, again, something we might expose to our clients later on. So for that particular guy, what was his name? This one. So one way is to search it through the UI, which is what we provide you here. The other way would be to gather data analytics, would be to use Kibana. And you see, this is all the logs we have for that particular service. Like any console output, any error, anything related to build process is provisioned right here. Okay, so this is the microservice. What about the web app? So again, it's not going to work immediately on the first call, but maybe it will actually. And it is. So, and this is the client app, and we do provide you with generated DNS for that, which consists of your name of your service, your environment, and your application, your deployment name. And we do provide you with SSL as well. So,
where's this actually hosted?
On Cloudflare.
So it's accessible worldwide, very
Yeah.
fast, automatically.
Yeah.
With the CDN.
Yeah, pretty much. Currently we host on the Google cluster in Taiwan, but the way the system's set up right now, we can deploy that pretty much to any environment supporting Kubernetes. We're not bounding particularly to Google. We don't have any boundings to a particular realization there. So yeah, AWS, I don't know, DigitalOcean if they support Kubernetes as well. But yeah, and our future going plans is to have it like as an installable instance that you can run on your own cluster, managing all your services using our infrastructure. All right, so that is the basic example. I think. So, questions. We might have like a smaller, yeah, let's just do the questions if you guys have so far. Any? The rest of the presentation is about TODO and stuff. Any questions? Anyone? Yeah, please.
Have you thought of supporting mono repos?
Mono repos.
Yeah.
What is it exactly?
I know that large companies recently they start using a single repo where they have all their projects. There's like many reasons for that, so I won't elaborate. But
Like with Git submodules or what?
no, not necessarily. Actually, physical directory.
Okay. So it's a. Let me get the problem. It's a big monolith, or it's a combination of multiple applications.
Just a huge repo. Companies like Google and Facebook they use a mono repo. Companies like KLM and Rabobank or Air France they slowly use that. So I was just wondering.
Well, they deploy that using some sort of config, right? Like YAML router.
In-house developed tools.
For that, yes, we do have plans for that, and we basically you would be able to provide a YAML config for us to understand where you need to deploy stuff. That's a future going plan, but it's on a roadmap as well. And yes, we do think about that as well. So basically, one repo with all the stuff, providing the config where the stuff should go. Yes, we do. We are planning to support that. Anyone? That answers your question?
Yeah.
Okay, cool. Anyone else?
We have got the Google's Firebase app and Heroku to push the Node.js, right? So why don't, what's special offering the KintoHub? And it's more about scaling and that bit of the Kubernetes Docker stuff, or what's the revenue model? What helps actually?
There are a couple things distinguishing us. First of all, agnostic. Like you, one thing we're planning to do is actually not only like for you to be able to deploy your cluster on a particular vendor, but actually deploy that cross vendors and calculate the optimal routing for you, including the DNS that those providers provide you with. So you would be able to say deploy in Asian region, you would deploy on Google because it's pricing conditions are better. In US, you would deploy on the AWS. And based on your request, we'll be able to route it the most optimal way to like the closest point possible. So it's like CDN on steroids, I would say. So your content is going to be not only providing it the fastest way, but also the most optimal way in terms of pricing. Because again, we can fetch all of this data. And the beauty of that is that all those vendors, they provide the similar thing, but they create all sorts of services around it. So when you go to AWS, you need to learn Lambda, you need to learn their Kubernetes deployment thing. Like on Google, you need to learn the entire Google Cloud. Those things providing the same thing are actually like a lot different, and you need separate people to manage those separate clusters. With Kinto, you learn it once, and you can scale it across vendors, which is something none of vendors will ever going to provide, because Google is always going to be on Google, and AWS is always going to be on AWS. So we can provide a layer on top of that, basically. So, and again, funny thing is we use KintoHub to deploy KintoHub itself. So we incrementally improve that based from the developer's perspective that are actually using that service each and every day. So Google is a big corporate company. They have like a lot of things involved into making decisions how to evolve the platform. But in the end, it's slower than a group of developers developing this tool for developers. So.
During development, can you make a local build without pushing it with a commit to the repository to test out
Build.
new
Theoretically, yeah, you'd be able to possible. It's possible. I mean, it's Kubernetes, and we are planning to do it as an installable version, but we most likely we're not gonna provide it in open source too soon. Maybe some like reduced functionality version that's gonna be available for mass consumers, and you'll be able to run it locally. So yes, to answer your question, yeah, you would be able to do it, but that's like next year's plan. Okay, anyone else?
The tough question, it's a bit of a business question. I know that KintoHub is currently free. Any plans to monetize that?
Yeah, we actually the version that is available right now is going to be revamped soon to support enterprise cluster management. So that's basically our business direction shuffles towards to. We're still going to keep for a certain amount of free version. Later on, it's going to be reopened, but our main focus is going to be managing corporate Kubernetes clusters for clients that we're already talking to actively. So yeah, after that, we're going to introduce the consumer version for mass developers. Well, right now, everything is free. So that's also one big advantage comparing to our competitors right now. Lifetime measurement. Right now, your service is gonna be on. We're still working on shutdown functionality. So meaning your service, if it doesn't consume anything, any requests, is gonna be shut down and then reactivated when somebody calls it. So it's not gonna consume additional resources. Or maybe I misunderstood your question. We keep a certain amount of idle pods for you. If the pod was shut down, incoming request is going to recreate. That takes usually around 10 seconds to respond, and it's on after that. 10 to 15, yes.
So if I have a website, set website in one service, and I visit the website, I need 10 seconds to see.
For first request, only for first one. So the rest it's always going to be on, so it's instant response.
It's long. Yeah, I don't expect such long.
Right now, there's no shutdown. There's no shutdown right now. Like we are trying to we're gonna provide different schemas for you to work with. Say if you wanna do more economy on your resources, you probably would wanna use that. If you don't, you're just gonna use the always on, which is currently the case. But say when people are using shared instance with shared memory, they want to consume like the least amount of resources and not use that service if that's just going to waste their budget. So for those kind of cases, we're going to still provide this kind of functionality for shutting down your pod if you don't want to use it, if you're not using it. For the most cases, and right now is the case, it's always on. So whenever it's spawned the first time, you're always going to be able to call it. It's not going to get shut down. Make sense?
Okay, if that was the last question, I want to give a big round of applause for Roman, of course. Thank you for talking.
Thank you. So it's not the end, just FYI. Oh. We have a big next part of that is actually, which is the actual example. But I'm gonna go through that. Not with all deployment. I'm just gonna show you what's the result you can get, what's the functionality involved, and how you can get to that result, basically. So it's a React To-Do app, which we have right here. So this is your Redux React To-Do app, which is pretty straightforward. the particular difference for this React app is that, first of all, it's deployed as a microservice in Kubernetes. It has a separate Node.js service consuming the updates from that to do, and has MongoDB connected to that to do the resync with the optimistic updates, actually. Meaning it's like, if you guys know, in GraphQL, you can do optimistic updates on subscription. So I implemented that using this example as well, while it still does the synchronization with the backend data. So I don't think I need this. So basically, if I modify anything here, it's updated immediately, but actually it does the synchronization with the backend. So, and even though if it has the local storage available here, if I'm gonna go again to the switching of the anonymous windows, it's annoying. So if I'm gonna go to anonymous environment where I don't have the local storage, I'm still gonna have the same data, which is right now. Actually, anyone can access it and update the things. But yeah, the beauty of it is that it has all the the basic functionality, but it has the whole power of Kubernetes and microservices behind it. So how did I implement that? Let's check it out. So it's pretty straightforward setup. We have our to-do client, and we have our to-do list, which is the backend service. So when I go to the backend service, see it's all documented with the API doc. All the examples, by the way, they are. If you wanna follow along with that, I think you can find me on GitHub, and these are 2 repos that are available for you to use and check. It's exactly the same example. Okay, where was it? Here. So yeah, this is your Node.js server built with Happy. Usually I use Express, but this time decided to go with Happy, probably because my friend Nadim convinced me to do so, and he did most of the work actually here.
Could you make it a bit bigger?
Yes. Yeah, if you guys, it's hard to see for any one of you, just let me know, because it's hard for me to understand if it's visible from there or not. So yeah, I can go in particulars. How do you do the gets and particularly the post requests, and we have 2 different flavors, post and put. So in order for our gateway to route properly your request, you do need to specify the request params you are expecting for that endpoint, and the methods as well, and basically the params. On the client side, you're probably gonna want to check out the middleware. So this is how you do a basic put request. So you have your base API URL, and this is how you access that endpoint. So in my example environment, so let me do this. In my example environment, you have your environment variable specifying the Preact. React is grabbing the React script is grabbing environment variables using those 2 keywords at the end. Just FYI, if you want to use the .env, so you specify your endpoint that you want to access and your authorization token. A huge recommendation is to test your thing locally before you deploy to make sure it's all working together. Probably not gonna go through that. Let me know if you guys want to see it. I don't think you want to waste time on that too much. But yeah, this is the pretty basic setup how you connect to any endpoint. And yeah, don't forget to provide your content type. With that, how it works after that. like I'm going to show you how the setup basically works in KintoHub. So I created, as you saw before, I created the web application, and this is the serving application. For the serving one, you want to activate the MongoDB, and you want to provide some environment variables. Also, another recommendation is to currently we don't expose you the database access directly. We generate the password for you. Like the full connection string like this is going to be generated for you. This is the one I was using to test my data model is working in remote correctly. So I used MongoLab for that. And I do recommend you to use that first to test that your all the data flow is working correctly. And you can deploy that in a separate environment. For the main environment, and this is, I think, yeah, it's on master. So currently, I kind of disabled that environment variable by adding this thing. So this is going to actually use the connection string that we provide you on the back end with the service, which is, I'm going to show you in the code how it happens. So if I go to database, you see here, this is basically how you get your connection. So this is the one I can use either locally or in remote to test that with any third-party service. We don't limit that in any way. But if you want to use our MongoDB dedicated service, you would want to use this particular environment variable, and it's documented in our docs, particularly what you should be expecting. But this is like an easy switch for you to be able to differentiate between different sources, and you can deploy. Basically, you can deploy to one environment with this source and to other environment with another source, which I actually have here. So this one is the Mongo lab environment. It's using the different. This is use the Mongo lab environment variable, and this is basically the data shape that you have in remote. Currently this is connected to MongoLab, but this guy is using our MongoDB, and on the setup for that environment, yeah, I actually already showed you. So this environment variable is basically disabled, but if I'm gonna switch to MongoLab one, you're gonna see I am using this one. Questions so far? Everything seems reasonable? Okay. So let's check out the deployment. With deployment, it's pretty straightforward process, as you saw that there before. You add your services here, you specify the branch, and then when you tag and deploy, you check which environment you want to deploy to. And for that particular one, we have two, which is first one is this one, and this is the second one. I think that's the one I expose here. Give me a second. Oh yeah, I want to show you all the documentation. So for each endpoint that's coming from that server, you have the complete description of what requests are coming in, and you can provide like additional description there, which makes a much easier job on any front-end client who would be working on, say, this application to understand how your app works, basically. For web apps, we don't enforce any API docs, so you can deploy whatever there. Think that's mostly it. Yeah, so far, does that process make sense to you guys? All right, so let's conclude a bit. So tips and takeaways there. You need to understand how much resources your app is going to consume. So each pod has those limitations right there. My personal suggestion is to put all of your builds in build command, because that's what our task runner is going to be using, and it has much more RAM than the pod. So don't put it on your run command, like run the pre-start on npm start. So try to put it on your build. Build your things stateless. You need to, with microservices, you need to understand that there is a case that your pod, your service might be shut down, and Kubernetes is going to manage that and respawn the new one. Each and every service should be able to consume any request and forward it to the right spot. So that's different from the monolith apps when you have your state with session, users, all of those things. You can still store those either in Mongo or Redis or any other third-party service, but try to not store anything on the pod itself, because that thing can die any second, and you don't know, like it can auto-scale to more, it can reduce the scale, and Kubernetes is managing that by itself. So in future, we're going to provide corporate clients with ability to specify the pods, because it's going to be deployed in your cluster, and it's up to you to figure out what limits you want to have there. By default, in the free version, we have this limit. Yeah, and run the prod server. Again, due to those limitations right here, you don't want to run the dev server because it consumes much more memory. Currently, we don't route to local hosts, so again, check which URL you're going to be using there. And yeah, I already showed that in order to access the service, you store that in environment variable, and it's going to be, while it still has the expiration date, we don't enforce it right now, maybe in future. So right now it's going to be valid forever, and you can always regenerate the new one. So I showed already, actually in my case, it spawned pretty quick. But there are cases when the first request, as I mentioned to you, might fail, but the subsequent requests are going to always succeed. So for web apps, usually it takes time, especially if it's a complex web app that requires a lot of resources. It takes usually around 1 to 2 minutes, but this one spawned pretty quick. Do test your things with Mongo, with third-party Mongo first. Before you want to use it on a single cluster. Make sure your data models make sense and it actually works properly. For testing, I usually use Postman, but be aware of the course issue. In my Happy server, I actually specified to accept the course requests, because they might come from any different directions, and you want to be aware of that, because Postman is not going to throw the exception to you. So MongoDB provisioning, that thing also takes time. So when you actually, I think I didn't actually show you that, but when you go to your deployments and you activate Mongo, it takes time to be provisioned. So in UI, we currently don't have the response to tell you that, which is, again, like there are so many things on our table to improve, and that's one of the things to improve, which is the real-time updates on the status of any service you have. Future going, probably the question you have, like for any other databases, we're going to provide you with custom services where you'll be able to, using Helm, if you guys are aware, they have a repo with catalog of like a lot of services there, and you'll be able to basically use it as a catalog to provision any service. It's like if anyone familiar with Rancher, they have also the catalog of pretty much Mongo, Postgres, like any boilerplate websites, maybe even. Sorry, your question.
I just want to know where MongoDB is hosted.
It's it's on your cluster basically. It's as it's deployed as dedicated service, which is always on. The databases are provisioned per environment, and per user basically. When you deploy your application, we provision you with the separate, like the full connection string to that database. No one else have access to that, and we don't have access to that. But and again, if it's on your cluster, that's that's your cluster.
What's the size we get?
Well, it depends on your cluster. So I think maybe one of the DevOps guys can respond to that later. There's no whatever your cluster allows you to provide, that's what we're going to be consuming. And we are using the storage of that cluster, basically.
I mean, if you take MLab or something, it has given with a fixed size which you can use, right?
Future going, we'll be able to provide you through the UI the configuration for basically when you would be able to provision the service, you'll be able to specify the limits of your service there. And something else I want to say that. Oh. All right, forget it. Does that answers your question? Cool. So this whole section is going to be changed, and it's going to be basically a catalog of services you can provision on top. Right, let's go back. Yeah, I already mentioned the Git access. Make sure you do have access to a particular repo, because that might cause issues and confusion. So the main features we currently have is that we provide you with the, as you saw currently, to me, I don't have much DevOps experience. I do have some, like managing Rancher, but for the most part, I'm concerned about doing the actual logic. So our whole platform removes the clutter of you setting up your own Kubernetes, setting up like the communication between services. Mostly, you are focused on just doing your logic, which what development should be about. You should not be bothered with servicing the platform or any environment. You should just write your code. CI/CD and logging and the auto documentation, those things are already provided by the platform, and we're gonna add extensive amount of additional features to that. It's free, but currently, like next few weeks, we're planning to close the public access to. It's still gonna be available, but if you register today, you still will have access. But by the end of the year, we're gonna close the sign up, and we're gonna be focusing on managing the enterprise cluster management with using our infrastructure. Again, I already mentioned that it's cloud agnostic, so it's a huge benefit in my mind that you can deploy that as an installable service to any cloud provider, pretty much. Serverless, again. Again, I already mentioned a bunch of those features. In the bulk of it, that's the platform currently provides you with the complete setup for running your prototype, providing you with the backend, front end, database, and HTTPS for encryption. So in the future, this is what we're focused completely on right now. Also real-time build updates. GraphQL is already kind of working on our staging, and we're working with that for our next releases. Custom services, which I already also mentioned. Zero downtime deployments. So to address also your questions, maybe when you are deploying the new thing, how the old thing is going to behave. There's going to be a percentage that you're going to see real time shutting down your old pods, and the moment those shut down, the new ones are gonna be active by that time. So users won't see any downtime. Actually, just gonna switch instantly. I mean, that's what we're working on as a solution, and should be doable actually. And A/B testing related also to the deployments. You would be able to deploy a couple different, like A/B/C testing probably. You'll be able to deploy different versions to the same environment and kind of route the percentage of the traffic that's going to go to one environment and another environment, and see the user's feedback, and maybe even select the regions with that. And already it was mentioned the customizable autoscaling in the hardware. Yeah, that's pretty much it. and questions so far.
How much time did it take you to build a whole app?
I think day and a half, the whole thing. But I was adding like additional APIs there, and I was doing a lot of testing in bulk. When you have your server already tested and deployed, it takes 20, 30 minutes to set up like the whole environment. That's it. You guys, yeah, anyone. Okay, I think we can wrap it up then.
Big round of applause, please.
Thank you.
Awesome. Thank you for showcasing that. I was a bit taken aback by the first question time, so I thought, oh, there's some pieces missing. Any way to reach out to you?
Yes, so my email is simple. It's Roman@KintoHub, and you can reach me on Twitter or add me on GitHub.
Awesome. Thank you for speaking.
Thank
All
you.
right, we still have a few drinks left, so please help to finish them. Thank you for coming again. If you want to do a talk yourself, if you have to talk anything about JavaScript, let me know. I'm more than happy to host you as well. Even smaller things, lightning talks, that's all welcome. And again, thanks for joining.